Firstly, if there's any budding photographers out there, please can you put more photos up on Unsplash? Because, yeah, I've never had two talks back to back that you've used the same picture. Good taste, I'm going to say. Right, I'm Nicky Wrightson, and I am terrible at overnight support. The first time I went on an overnight support rota was about a decade ago, and I was working for a bank. I can tell you very little about the time that I got first called, though, because apparently I answered the phone, although I have no recollection of this. The thing is that we pieced together the following day that I had answered the phone. The only trouble was I hadn't woken up, so I thought I was taking a mission from James Bond. Needless to say, I did not action that P1 that was outstanding, but the ops team didn't know that I wasn't. And this was where my sort of love of resilience, or at least looking into resilience, started. Since then, I had the pleasure of working on a greenfield project at the FT. What we were doing is designing all of our content APIs, the sort of backbone behind ft.com and a load of other products. We were designing it from the ground up. And we weren't just redesigning the tech behind it, we were also rolling out sort of DevOps culture and also the support model that we were going to use. Recently, very recently, I have joined Skyscanner. And I'm really pleased to see a lot of the stuff that we did at the FT also being done at Skyscanner, but with slightly different permutations, of course. The diagram that you are not supposed to be able to read at all is a diagram from February of Skyscanner's Java services talking to each other, just the Java. We are building these mental pictures, mental distributed systems. We are unable to keep all of this stuff in our heads. So we need to understand how to support these systems too. When we talk about microservices, the thing about microservices is that they're not solving a technical issue. They're actually producing complexity. Martin Fowler talks about the trade-offs of microservice architecture, and one of those is operational complexity. We're deploying more and more stuff more and more regularly to more and more places. This is hard to understand, let alone support. But we're now working in a way that the teams have empowerment. They can design how they support systems, not just how they build systems, but how they run systems as well. When I joined the FT, we were at quite an early stage of producing these content APIs, and we were super flaky. So flaky that our consumers were adding caching in front of us because we were down more than we were up. And this was sort of around 2014. But we had to change. So we had a launch of the new ft.com site. And they demanded some SLAs off us. And one of them was a recovery of 15 minutes, which is pretty damn tough when you've got big graph databases and such behind you. To make matters worse, we had done it in our own container system, which was a bit foolhardy, and realized the problems, and we had to migrate over to Kubernetes. We had to migrate over to Kubernetes while still maintaining that SLA of 15 minutes. Now, I spoke to some ex-colleagues of mine a couple of months ago about the calls that they'd received. I feel a little bit worried about making this statement at the moment, because I've noticed that the entire first line ops of FT are in the room, so they might correct me on this. But I was at a party and I spoke to my ex-colleagues, and they said that basically the only calls they had received were from new members of the ops team that were just a little bit nervous about whether they'd made the right decision. There was actually no outages that had been happening overnight. Anyway, so what we didn't build this mythical, magical system of perfection at all. But what we did build is a system that could limp into the next day. It could provide us with an ability to have a good night's sleep. And I realised that there was sort of five sets of approaches that we used to get there. And that's what I'm going to describe to you today. When I first came up with the idea of this talk, this was about, engineer's mindset was about halfway through the deck. But actually I realised that this is the most critical part of this talk. Because I could tell you loads of great techniques on how to make your system technically resilient. But if engineers aren't thinking about it, none of it will get implemented. Unfortunately, some of that, often that passion for implementing these things comes from a couple of battle scars, though. And until you've got those, you're not thinking in the same manner. Hopefully I'm going to share some of my battle scars, though, to entice that passion. I love charity majors, but I'm not a sysadmin. But I wholeheartedly agree here. We need to start thinking of operability as a primary concern. It's not something you tack on later. You don't work out how to support it after you've built it. And we shouldn't be saying this is how we're going to support every application in every place. We need to empower the teams to define this support model. If they understand how, because they're best placed to understand how, when, and what we do under sort of failure times. They need to own this. So this is an example of where I've seen it work very well. This is what we came up with at the FT. The team that I mentioned that's in the room, they're the top there. And what we used to have is two teams of engineers. And what operations would do is they would round robin call those buckets of engineers if there was a problem. And if you couldn't answer the phone for whatever reason, you just didn't. And the next person would get called. So this allowed you to spontaneously go to the pub. This allowed you to go for long bike rides, go out with your kids, and not worry about having to be chained to your laptop. Equally, this was completely compensated and voluntary, which I think is important. We're asking people to do things above and beyond their day-to-day. This should be recognised. Our support model, though, we didn't just have it out of hours. The team, we extended it into hours, and we had two members of our team constantly looking at issues. And they were looking at sort of people, inquiries, actual incidents, maybe the night before, but also just general improvement to the platform. And these people were dedicated to this task, because we've recognised that if they weren't dedicated, no improvements would be made. They could also extend that influence to improve the support model as well. We were constantly iterating on our support model to make it work for everybody involved. And when you're working on this during the day and you're on that rota, it affects how you develop stuff when you go back to your home team. You start thinking, oh, I don't want to have to fix this the next time I'm on rota, or worse still, I don't want to be called at 3 a.m. because my dodgy code isn't handling an error condition right. Once you've got those error conditions, you want to make sure that you are alerting at the right level. So we had certain errors that we really wanted to action. This example, so CoreOS is container Linux that we were running on our containers. It's very popular, but we wanted to know when there was a version update, especially a security update. But the security update doesn't need to be applied at 3 a.m. It can wait until the next day, but we want to know about it. Hence, we had a warning purely rather than a critical. If something went critical, that's when it initiated a call. So now we're thinking like we own the system, we know how to run it, we have our support model in place. What next? So let's think about the things that we can avoid. Most of the stuff that causes problems in the middle of the night is stuff that we've done during the day. If you never make changes to a system, it's never going to, it's less likely to break. Caught myself there. So let's just have a look at some of the things that might happen during the day and see how we can sort of reduce the risk of that call. So releases, it's the biggest reason, of course it is. And with the best will in the world, we're never going to completely eliminate releases causing outages, because there could be sort of a slow leak of a problem that might even take days or weeks to show up in production. Or there's just unforeseen circumstances or unforeseen scenarios that we haven't thought through. So releases are probably going to be the #1 culprit for that call out of hours. However, we can also work on reducing that. Now, how many of you would be worried about deploying your code at 5 p.m. on a Friday? Okay. And that is fair enough, because quite frankly, it is actually down to risk. What's the effect of my release? How quickly can I roll it back? And those kind of things. But I have a belief that there's also another thing. Sometimes a fear of 5 p.m. releases can be an indicator of development processes that could be improved. Why does the team have low confidence? But you can also, if you have got low confidence, you can use tools and still release. Things like feature flags. Put your stuff behind a feature flag, turn it off when you go home. That's good. So yeah, you can control behavior and slowly roll out your changes. At Skyscanner, we have our own CD system, and it's quite clever. And what it does is it throws out a new service into production, because we only have production. Yeah, I kid you not, it's brilliant. Anyway, so we throw our service out into production, and we start pumping metrics all over the place. And our CD system will monitor those metrics. And if we start seeing a hint of instability, it will do an automatic rollback for us. So our stuff gets brought but straight back in, which is fabulous. The other thing is that once you push stuff out into production, work out how to work out whether it is actually working. And this can be as simple as manual accounts in your production environment to test things. You can use sort of monitoring as well to give you quick feedback on your releases. There's quite a few mechanisms. There's an amazing talk by Cindy about how to test microservices in the same manner. And there's also a talk by James Governor called Progressive Delivery. I've got a whole list of resources at the end of this talk if anybody's interested. But we're talking about things like A/B testing, canary testing, and such like, so that you can get feedback on your release as quickly as possible. And that gives you confidence to go home straight after that release. The other thing that really increases your risk of getting called is those big batch jobs at 3 a.m. If you shift all of your heavy lifting into the time where you don't have any support or very little support, you're bound to be called at some point or another. What I'd kind of suggest under these circumstances is to try to bring any of that computation over as much as you can to real time. So, for example, if you're sending off a reconciliation file at 3 a.m., build it up during the day with all the items that go into it, and then the 3 a.m. task will just be purely sending that file to wherever it needs to go. So try to minimize the reasons why you'd be called in the middle of the night. Yeah, releases and batch jobs are culprits, certainly. So now we are thinking about it, we've reduced the risks. What do we do next? we need to automate. We can automate, because at the end of the day, a computer is going to work a whole lot better at 3 a.m. than my brain. So what can we do to automate failure? We're really lucky in the ways that we're working nowadays. The tooling that's come along with us moving into the cloud is incredible for automation of failure. You look at any container system will reschedule your pods, services, what have you, onto another VM if it gets lost. It will automatically restart when things are looking a little bit honky. And with serverless, that's the same, but you just aren't seeing that happening underneath the hood. So we're really lucky. However, you need to write code that these systems can kind of manipulate your services. So trying to make things ideally stateless. Stateless makes life a whole lot easier. But otherwise, it's try to make sure your data doesn't get half-baked. So transactional and queue-backed is a good sort of mechanism. And most importantly, these things need to be thrown around to different places. So they need to be able to gracefully terminate and have clean restarts. If you do this, it will improve the ability to sort of automate the recovery of your services. Oh, I missed a really important one there. Idempotency. So idempotency is the idea that you pump something into a service multiple times and it will have the same outcome. And this is really useful for if you want to replay any failed events or such like, so that you don't have a fear that it's going to change something in a different way when it comes out the other side. The other great thing that has certainly saved the content platform at the FT a few times is regional failovers. And that means deploying some or all of your stack in another area. When you're seeing some form of failure, you can literally switch the traffic over. Slight word of warning, make sure you test this. You suddenly wait for the automatic failure in the middle of the night and realize your cluster can't take all the traffic, you're in trouble. So, as I was saying, we did this at the content program. And we had all of our stack replicated. We had everything in the US and the UK, and we were active. So we were sending traffic geo-balanced to both of those. We had a load of databases. Well, it was a lot of things. It was about 180 microservices to put the size and scope into play. And when things went, if we saw problems in EU, we'd just automatically swap the DNS over to the US. It does come with a word of warning, and that's not just the warning I gave you a moment ago. You can sometimes infect both platforms at the same time. If you're doing updates, don't do them at the same time. Whether it be your code changes or any updates to the operating systems or what have you. Don't do it at the same time. Do rolling updates, because you break one, at least you've got one still there while you fix the first one. The second thing is that sometimes infections can spread. So one of the biggest outages I've ever been involved in was from a long-running query. We had tried to containerize a graph database, and this long-running query just kept blowing it up and taking down VMs with it. And so we swapped over to the other region. Fortunately, exactly the same behavior. It was only when we started serving traffic out staging that we realized we had to shut it down. Healthchecks and liveness probes, they give you some of the picture. And they're particularly useful with sort of web services and such like. But when you get into highly concurrent processes that are consuming large amounts of data, you sometimes just see some funkiness. So the garbage collection can kick in, for example, and suddenly you see you're consuming data at such a slow speed. So what we've done on the data platform at Skyscanner is that we have Kafka as our main sort of messaging broker, and we're consuming a lot of data. Last week we peaked, coming through this Kafka, at 2 million messages per second. It's a lot. And we have a lot of consumers consuming off it and doing stuff with it. Now, we also take the metrics from Kafka, and when we start seeing that there's lags, we alert. But not before we try restarting the consumer process first. I know this sounds crude, but it's better than being woken up at 3 a.m. You can investigate the reason why it was restarted the following day, but if that gets you out of the weeds at that point, then do it. It only tries once, though. It doesn't suddenly end up just constantly restarting. So automate failure wherever possible. The computers can do this much better than us. We don't want to do this manualness in the middle of the night. Next thing, what is failure? We're talking about alerting and such like, but we can't do that without understanding what failure means within our system. And there's all sorts of categories of failure. So you need to understand what is really important for your consumer. At the FT, the brand is critical, and the most critical thing is to break news. So anything compromising that pipeline of a journalist being able to break news is very, very critical. But it depends on your industry. Skyscanner, it's traveller first. So if we're interfering with a traveller's journey, we need to know about it immediately. These things can be hard to tease out of your customers, though, because when you ask them what's important, they will say everything. But this drives that you don't want your customers telling you when there is a failure. You want to be the first to react. And how do you react at the very start of a problem? This is actually, it looks like a quote. It is not a quote. It is a mantra. I worked with Sarah for quite a long time, and I found this quite an odd thing at first. Surely every issue we had with our services, we needed to know about it, because we needed we have to do something about them. No, there's so many alerts that we don't immediately action. No piece of software is perfect. Those things that you're not going to get to, or not even going to get on your backlog, just log them. You may get to them one day, but you're probably going to actually rewrite the service before you even get there. Just get the alerts you need. Otherwise, also, you get alert fatigue and may actually drown in the noise of all the other things and miss an important event. At FT, we did something called synthetic requests. Do this at Skyscanner as well. And this synthetic request means that we make up a request to go through the system all the time. And it could be just a created new request or a replaying of old requests. And what this does is gives a constant flow of traffic through the website, or through the system. Taking FT as an example, because it's mainly UK-based content that they're producing, that sort of 1, 2 o'clock on Sunday morning, not many publishers are coming through the system. So you end up in a sort of Schrodinger's platform state. Is it dead, or have we just not had any publishers through? So this was really useful, that we could actually monitor any traffic coming through the system, including the synthetic requests, and see any breakages. But to do this, you need to have the right tooling behind it. Tracing is critical. I aggregated logging as well, whether that be event-based or purely logs. You need to be able to understand where your failures are happening. I'm going to give a quick example of how we did it at the FT. A first stage and a second stage. So this is a much simplified down sort of diagram of that 180 microservices system that we built. We take some content from a CMS, it gets pushed to our notifier onto Kafka, and then we transform it, write it out to a database. Quite a simple sort of ETL flow. Then we put in a service that could tell us whether content had arrived within a certain time frame. The only trouble with this service is that it started out fantastic, but got very brittle over time and somewhat godlike in its approach. When you're building a monolith to monitor a microservices architecture, felt a little bit wrong. It was also taking up a lot of our time because it had become tightly coupled to our business flows. So what we did is actually we moved our monitoring towards event-style monitoring, and we created structured log events that we could sort of error out. So here we're trying to save to a graph database and it's failed. This is something we want to alert on. Everybody normally asks me about this. It's Go, by the way, before somebody asks me later. And what we do is take the logs, we put them on Kinesis, and then we can run streaming SQL over those logs to see about those events so that we can see within a certain time frame, are we okay? It moved a lot of the flagging of the events and these issues close to where the business logic resided. There was some logic in the SQL, but much more of the logic was by the actual code. So we now understand what failure means to us, but there's still going to be failure. So what do we do next? Yeah, practice makes perfect. So we want to break things. The idea of chaos engineering is pulling down discrete parts of your system and seeing how it reacts. This can also be done for your support model. You can test your support model in the same way that you test your code via this mechanism. And you'll expose those weaknesses. But when do you do this? This is a sort of typical monolith to microservice timeline. You've got a big chunk, take them off, then those microservices evolve further. But when do we start using chaos engineering in this timeline? It's certainly not over on that end, where we've just got a monolith. We've only got one thing. We take one thing down, we know what's going to happen. But it's not necessarily all the way to your finished state. The point in which you want to start doing this is when you want to start testing your resilience. Am I resilient enough to stand the sort of experiments our chaos monkey will do? Manual simulations also work. We did a lot of this at the FT when we initially went live with all of our services. And we did it both from the applications, but also we tested the relationship between the teams and the ops team. We did secret outages, which were mostly okay until one of the developers kindly told everybody that what we were doing and why we were doing it kind of defeated the object. So there's something nice about the culture, though. But yeah, you can take down sort of aspects, pull them out, and do these tests. So this is, going back to sort of the simplified diagram that I had before, we actually had a single point of failure in our content platform. It was this notifier. Basically, if we scaled it up, all of our content got in the wrong order. We could fix it. It's really easy to fix, but the fix was really widespread. And it didn't cause us much pain. Because, remember I said about this earlier, we could also do manual failovers. So what would happen under that circumstance is that we could shift all of our traffic to the US, change that single point of failure, then shift all the traffic back. So we were doing these manual sort of system failovers for code releases. It sounds far from perfect, but what this did was actually got the teams practicing continuously these manual failovers. And it meant that the command that they were running to do these failovers went from sort of that to that, to that, to that, to that. Trust engineers to reduce what they have to type. But that's really important at 3 a.m. Because at the end of the day, if you do need to do something, you just want to press a button. Because there's some evidence out there that says when you're woken up from a deep sleep, it's the equivalent to a couple of pints of beer. Well, that's if you do wake up from deep sleep, of course. And you want to make any intervention really easy. This is another example of making something easy. We used to just have a Jenkins job. All it did was republish content through the system that had failed. And as we had idempotent system, we could do that as many times as we needed. But you need to, when you get that call, you don't want to be jumping on your laptop and trying to aggregate data from sort of 5 different data sources to try to work out what's going on and what the issue is. So making your alerts as verbose as possible, indicating all the things you need to know about the issue that's at hand, means that you're able to make a call. You're able to make a call going, does a failover fix this for me? Do I just need to restart something? Do I need to replay content through? Or simply that, do I need to call somebody else? And they're the kind of questions your alert needs to answer. But the most important thing is, do not try to fix things at 3 a.m. Trying to write code at 3 a.m., or actually not even getting to that point, trying to investigate a severe issue in the middle of the night by yourself, sat in your pajamas, it's not going to work. Or it's not going to work as well as it might be. So you just want to teach your system to limp into the next day, where you have caffeine and colleagues. So that's it. We practice your failure scenarios. That means you can react more confidently. So just to recap, everybody needs to start thinking about operability as a primary concern. We need to understand how to operate and support our systems, and we need to own that support model. Don't get caught for releases, or well, you're still going to get caught for releases. Don't get caught for things that could have been caught during the day. Try to put safety nets around those procedures. Automate. A computer can do it better. Understand what failure really means to your system. Practice. Practice makes perfect. We're the ones that get called. So we should own this. This is the most important message of this, is that we need to own the entire thing, including how we react. Thank you. Obligatory, we are hiring. Couldn't go away with that. And at the end of the slides, I have got some resources. Thank you very much.